When Nazi Germany unleashed its blitzkrieg across Europe in 1939, Britain faced an existential crisis that would test every fiber of its industrial might. The British Army, still recovering from the Great War's devastating toll, found itself desperately short of the most fundamental weapon of warfare, the rifle. What followed was one of the most remarkable manufacturing achievements in military history. Between 1939 and 1945, British factories transformed from peacetime production to a thundering war machine, producing over 4 million Lee-Enfield rifles that would arm not just British troops, but soldiers across the Commonwealth, from the deserts of North Africa to the jungles of Burma. This is the story of steel, sweat, and precision engineering, the untold tale of how Britain's factories became the backbone of Allied victory. The Lee-Enfield rifle was already a battle-tested legend by the time World War II erupted. First adopted in 1895, this bolt-action masterpiece had proven itself in the Boer War, the trenches of the Somme, and countless colonial conflicts across the British Empire. The No. 4 Mark I variant, which would become the primary production model during World War II, represented decades of refinement and battlefield feedback. With its distinctive 10-round magazine capacity, twice that of most contemporary rifles, and its lightning-fast bolt action, a trained British soldier could fire up to 30 aimed shots per minute. The rifle's .303 British cartridge delivered devastating stopping power at ranges exceeding 500 yards. But manufacturing this precision instrument on an unprecedented scale would require nothing short of industrial revolution. At the epicenter of British rifle production stood the Royal Small Arms Factory in Enfield, Middlesex, a sprawling complex that had been manufacturing weapons since 1816. By 1939, this historic facility employed over 20,000 workers and operated around the clock in 3 shifts. The factory floor resembled a mechanical orchestra, with hundreds of precision machines working in perfect synchronization. Each rifle required approximately 200 individual components, machined to tolerances of thousandths of an inch. The main barrel-making shop alone stretched over 3 football fields in length, its roof supported by cast-iron pillars that had witnessed a century of warfare evolution. Here, solid steel billets were transformed through a 15-stage process involving drilling, reaming, rifling, and stress testing into the heart of the weapon that would defend the realm. Creating a rifle barrel was an art form that married metallurgy with precision engineering. Each barrel began as a solid steel billet, carefully selected for its carbon content and structural integrity. The first operation involved drilling a pilot hole through the entire length using specialized deep-hole drilling machines that could maintain perfect alignment over 30 inches. This was followed by reaming operations that progressively enlarged and smoothed the bore to exactly .303 inches in diameter. Then came the most critical operation, rifling. British factories employed the traditional cut rifling method, where a single-point cutting tool was drawn through the barrel multiple times, gradually carving the 5-groove spiral pattern that would spin the bullet and give it stability in flight. Each barrel required approximately 4 hours of machine time and passed through the hands of a dozen specialized workers before it was ready for assembly. As millions of British men marched off to fight in North Africa, France, and the Far East, the nation's factories faced a critical labor shortage. The answer came in the form of hundreds of thousands of women who stepped into roles previously considered exclusively male domains. By 1943, women comprised over 60% of the workforce in British munitions factories. These remarkable individuals operated complex machinery, performed intricate inspections, and mastered technical skills that would have seemed impossible just years earlier. They worked 12-hour shifts, often in dangerous conditions with minimal safety equipment by modern standards. In the barrel-making shops, women handled white-hot steel forgings. In the stock-making departments, they operated massive wood-shaping machines that could remove a finger in an instant. Their contribution was immeasurable. Quite literally, Britain could not have produced 4 million rifles without them. While Enfield was the heart of rifle production, Birmingham's small arms company represented British manufacturing at its most innovative. Founded in 1861, BSA had evolved from a gun-making cooperative into one of Britain's largest industrial conglomerates. During World War II, BSA's Small Heath factory in Birmingham became the second largest producer of Lee-Enfield rifles, manufacturing over 1.2 million units. BSA brought mass production techniques that revolutionized rifle manufacturing. They pioneered the use of drop forging for rifle components, reducing machining time by 40%. Their engineers developed specialized jigs and fixtures that allowed less skilled workers to produce parts with unprecedented consistency. BSA's innovation in heat treatment processes improved barrel life by 25%, meaning rifles could fire more rounds before accuracy degraded. The Birmingham facility produced rifles at a rate of 10,000 per week at peak production, a testament to British industrial ingenuity. While the mechanical components demanded precision metalworking, the rifle stock required equally specialized craftsmanship in an entirely different material. British rifle stocks were traditionally made from walnut, though wartime shortages forced the adoption of alternatives including beech and birch. The stock-making process began in timber yards, where wood was carefully selected, seasoned for months, and inspected for structural flaws. In the factory, rough blanks were shaped on massive copying lathes that could reproduce the complex contours of the stock in minutes. Hand finishing remained essential. Skilled craftsmen used chisels, rasps, and sandpaper to achieve the precise fit required for the metal components. The stock had to be strong enough to withstand the rifle's recoil, light enough for soldiers to carry on long marches, and shaped to provide natural pointability. Over 400 operations were required to transform a block of wood into a finished stock, representing nearly 30% of total rifle manufacturing time. In weapons manufacturing, quality control wasn't merely important, it was literally life or death. British rifle factories employed armies of inspectors whose job was to catch defects before they reached the battlefield. Every component underwent multiple inspections, using gauges calibrated to incredible precision. Barrels were subjected to proof testing, where they were deliberately overloaded with excessive powder charges and fired remotely to ensure they wouldn't explode during normal use. Headspace, the critical distance between the bolt face and the chamber, was checked with specialized gauges on every single rifle. Completed rifles underwent function testing, where inspectors cycled the action hundreds of times, checking for smooth operation. Finally, each rifle was test-fired at the factory's firing range with accuracy benchmarks that had to be met before the weapon could be accepted. Rifles failing inspection were either reworked or, in severe cases, scrapped entirely. This uncompromising approach meant that British soldiers could trust their rifles with their lives. Britain's rifle factories operated 24 hours a day, 7 days a week throughout the war. The night shift carried particular significance. It was during these dark hours that production targets were often met or missed. Night shift workers faced unique challenges: fatigue from disrupted sleep patterns, reduced lighting that made precision work more difficult, and the constant threat of German bombing raids. During the Blitz of 1940 to 1941, factories like BSA in Birmingham and Enfield in London were prime targets for the Luftwaffe. Workers would continue operating machinery while bombs fell nearby, rushing to air raid shelters only when absolutely necessary. Some factories were hit multiple times, with production resuming within days despite significant damage. The night shift workers developed a particular camaraderie, forged in darkness and danger. Their dedication ensured that rifle production never faltered, even in Britain's darkest hours. War has always driven technological innovation, and British rifle manufacturing was no exception. As production ramped up, engineers constantly sought ways to improve efficiency without compromising quality. One major innovation was the simplified rear sight, introduced in 1942, which reduced machining time by 2 hours per rifle, while actually improving battlefield usability. Another breakthrough came in barrel production, when new carbide cutting tools allowed rifling operations to proceed 50% faster. Heat treatment processes were refined to reduce warping and increase component hardness. Perhaps most significantly, British engineers developed modular manufacturing techniques, where sub-assemblies were completed in specialized departments before final assembly, dramatically improving production flow. These innovations weren't theoretical exercises. Every minute saved in production meant another rifle in a soldier's hands. By 1943, British factories had reduced the time required to manufacture a complete rifle from 46 hours to just 27 hours, nearly doubling production capacity without adding factory space. While British factories formed the core of Lee-Enfield production, the Commonwealth nations made vital contributions. Canada's Long Branch arsenal near Toronto produced over 900,000 rifles, many designated for American Lend-Lease programs. Australian factories in Lithgow manufactured over 500,000 rifles despite being under threat of Japanese invasion. India's rifle factory in Ishapur produced hundreds of thousands more, arming Indian Army divisions fighting from Italy to Burma. These facilities didn't merely copy British techniques, they innovated independently. Canadian engineers developed improved machining methods later adopted by British factories. Australian metallurgists created heat treatment processes suited to local steel grades. This distributed production network had strategic advantages beyond mere numbers. If German bombers destroyed British factories, production could continue elsewhere. It also meant rifles could be manufactured closer to theaters of operation, reducing shipping time and vulnerability to submarine attack. The Commonwealth Rifle Production Network represented industrial cooperation on an unprecedented scale. The assembly department represented the culmination of thousands of hours of machining, forging, and craftsmanship. Here, components manufactured across dozens of specialized shops came together into functional rifles. Assembly proceeded along a linear production line pioneered by automotive manufacturing but adapted for weapons production. Each workstation performed specific tasks: installing the barrel into the receiver, fitting the bolt assembly, attaching the trigger mechanism, mounting the stock. Workers became specialists in their particular operation, achieving speeds that seemed impossible. A skilled assembler could complete their station's tasks in under 2 minutes. The assembly line moved continuously, with partially completed rifles progressing from station to station. At the line's end stood the final inspector, whose approval or rejection determined whether the rifle would serve His Majesty's forces or return for rework. During peak production periods, a completed rifle rolled off British assembly lines every 23 seconds, a mechanical heartbeat that sustained armies across 3 continents. The 4 million rifles produced by British factories came at a price measured not just in pounds sterling, but in human suffering. Industrial accidents were heartbreakingly common in factories operating aging machinery at maximum capacity with minimal safety provisions. Workers lost fingers to punch presses, suffered burns from heat treatment furnaces, and developed respiratory problems from metal dust and chemical fumes. The constant pressure to maintain production quotas led to fatigue-related accidents. Some workers developed white finger from operating pneumatic duals, a circulatory condition causing permanent numbness. Women working with ammunition components faced chemical exposure risks. Despite these dangers, workers rarely complained, viewing their suffering as equivalent to soldiers' sacrifices on the battlefield. Factory first aid stations treated hundreds of injuries daily. Some accidents proved fatal, the ultimate price paid by workers who never saw combat but contributed as surely to victory as any soldier. Their sacrifice deserves remembrance alongside those who fell in uniform. By VE Day, in May 1945, British and Commonwealth factories had produced over 4 million Lee-Enfield rifles, a staggering achievement representing millions of man-hours, countless tons of steel, and immeasurable dedication. These rifles armed 8 British Army divisions that stormed Normandy beaches on D-Day. They equipped Commonwealth forces that fought across North Africa, driving Rommel's Afrika Korps from Egypt to Tunisia. They served with Chindit special forces during jungle campaigns in Burma. They were carried by paratroopers dropping into Arnhem and by commandos raiding Norwegian fjords. Beyond British forces, Lee-Enfields were supplied to resistance movements across occupied Europe, to Chinese forces fighting Japan, and to Free French units reconstituting after 1940's defeat. The rifle's reliability became legendary. Soldiers reported Lee-Enfields functioning after being submerged in water, caked with desert sand, and frozen in Arctic conditions. This wasn't accidental. It was the result of precise manufacturing standards maintained under impossible circumstances by workers who understood that their craftsmanship meant survival for soldiers they would never meet. The story of Britain's rifle factories transcends mere manufacturing statistics. It represents the triumph of industrial democracy, ordinary citizens transforming peacetime skills into weapons of liberation. When the last Lee-Enfield rolled off British production lines, it marked the end of an era where entire nations mobilized for total war. Many of these factories never returned to peacetime operation. BSA's Small Heath works were eventually demolished, and Enfield's historic facility closed in 1988. Yet their legacy endures, in museums, in the hands of collectors worldwide, and in the memories of veterans who carried these rifles across battlefields from France to the Far East. Today, Lee-Enfield rifles remain in service with some militaries and police forces, a testament to the quality built into them 70 decades ago by British workers who understood that excellence in manufacturing was itself a form of resistance against tyranny. 4 million rifles, each one a monument to human ingenuity, determination, and the unbreakable will of free people refusing to surrender their civilization to darkness.